Magic Containers is our simple but powerful app hosting service, and persistent volumes makes it even more capable. By default though, containers are ephemeral, so any data that's written inside, that's lost on a restart. Persistent volumes though fixes that, and we've taken great care to make them truly set and forget. Just add a volume, set a mount path, and you are done. It's that easy. No manual provisioning, no wiring. So we'll create a new app, we'll give it a name, and we'll choose single region deployment. The first container we'll add will be Redis, and we'll choose to add the environment variables and endpoints that are automatically detected when we choose the image. Now, if we scroll down and we choose to add a new volume, here we can give it a name, choose the size, which we can change later, and the mount path. We'll just call this /data. Since Redis writes to disk, we'll set replicas to 1 with our single region deployment. Running multiple replicas, each with their own volume, could lead to data corruption or sync issues. That's a good rule of thumb for any stateful service like a database or a cache. When you're happy, click Add Container, and we'll go ahead and add a new container. This time, the new container will be for our app that talks to our Redis database. Here I'll pick my registry on GitHub and the image that I want to deploy. This will be a simple Go API that talks to Redis for a simple KV API. I have an endpoint here that talks to the port 8080, and we'll want to add an environment variable for our Redis URL. All containers in an app use the localhost network, so here we can access the port that we deployed Redis to earlier with its Anycast endpoint on port 6379. These apps on these ports sharing the network are also available over the internet, so you'll want to make sure that you protect your databases and your applications where needed with additional environment variables, containers or proxies. Once you're done configuring any other environment variables that you may need, click Next and Confirm and Create. If we go to the logs for our new app, here we can see that Redis is starting and it's attached the volume data to the pod with the mount path /data. So here we can see Redis has found that volume on /data, and it's using that environment variable Redis URL that we set to point to the correct database. And if we scroll up, we can see that our app is successfully launched on port 8080, and if we visit the URL that Magic Containers create for us, here we can see in our browser the API response. And here we just have a few example endpoints that we can call to get, set, and delete from our Redis database. So if we launch the terminal and we use that same URL with the API format that the API expects, here we can set a value inside of our Redis database, and we can get that same value by passing the key. Now let's give it a try to undeploy our Magic Container app, and once this becomes inactive, we'll then deploy it. Once your app has deployed and becomes available once again, it will have that volume attached. That means if we go back to the terminal, we can make a request to get the value for the key that we set previously before we undeployed the app. And here we can see that that container data has persisted. If at any point you need to increase the size of your volume, head on over to the volumes page and click to extend the volume size and give it a new size. Once that saves, this will then update the container size and you'll have more storage space. You can also view the stats for your Magic Container volumes, and you can see the volume size over time and the volume usage. Under the hood though, volumes are designed to scale with your app. When replicas scale up, new volumes are provisioned and attached automatically. And when they scale down, volumes detach and persist, ready to reattach with all the data intact. And every volume is encrypted by default. This makes volumes ideal for data that lives right next to your app, database files, game server worlds, or user uploads. For replicated or distributed storage though, you might want to check out Bunny Storage with S3 support. That is a better fit for that use case. Bunny Database is also a great choice if you're looking for a fully managed database that replicates around the world. Links on how you can get started are down below. I'll see you in the next one.